Welcome to the Science of Tree Felling series. In this video, we're talking about the hinge. The hinge, as a function of our cutting plan, is the uncut wood that attaches the remaining tree to the stump during the felling process. In previous videos, I've emphasized that if you have a tree disconnected from the stump, so nothing holding it together, it will always fall in the direction of the lean as gravity acts upon it. How we manipulate gravity and can overcome a back lean or a side lean of a tree is ensuring that we rely on the wood associated with a hinge, and a hinge is exactly what it sounds like. It is just like a door hinge. Whereas the hinge attaches the door to the frame, the hinge of a tree felling operation attaches the tree to the base. And the hinge then allows the tree to pivot while it's moving, remaining attached to the base and providing control, keeping the two connected together. In a previous video, I talked about the angles of the face notch and how that manipulates how much control you get and the movement and the travel distance of the hinge being functional. And when the top and the bottom cuts come together, your hinge will likely break and you will lose all control. So again, review that video if you're unfamiliar with those concepts. But really, I want to talk about how we establish the hinge and how much hinge we have. The hinge needs to be flexible. So this is going to vary based on species. This is going to vary based on whether the tree is dead or alive. A lot of different factors that will come with experience and time. But in general, I'll talk about some things to look for. The front of our hinge is made by making a clean apex, by making a top cut and a bottom cut, using the felling sights on our saw so that both those cuts come together at an exact point extending from one side to the other. The front side of our hinge, being the face that's open, should be about 80% the overall diameter of the tree. This is a strange looking shaped tree, but in a circular tree it'll be a little bit more evident and easily measurable. So we can open up the hinge of our tree on the front side by making our top and bottom cuts. We create the width of the hinge based on how we arrange our back cut or our plunge cut. When I make a back cut, I have a couple of options. I can make a plunge cut or I can make a cut in directly from the back. I'll talk a little bit more about this in the next video, but if I'm coming in straight from the back and the tree has a back lean, no problem as long as I insert a wedge into the back so that the kerf doesn't close as I'm cutting. I'm able to set the diameter or the width of my hinge before I drive that wedge in and get the tree to come over. However, if the tree has a front lean and I start coming in from the back, maybe the tree starts moving before I have my desired hinge width. Again, I said that the hinge needs to flex. It is the same function as a door hinge. And if the tree is not allowed to flex, your hinge will break and do some weird things like barber chair and delaminate. So we have to try to achieve a hinge of approximately 10% the overall diameter of the tree. If it's anything more than 10%, we're going to have a situation where there's so much wood fiber it's going to resist the bend and it could potentially break and or barber chair. This concept we call chasing the hinge. So if we have a front leaning tree and we are running in this bar and now the tree is moving, we have to try to achieve that 10% hinge while the tree is moving, which is very dangerous. And again, I'll emphasize that in our next video. Conversely, I can set the back side of my hinge by boring in using the attack corner of my bar. I can bore into the tree just like a drill and drill all the way through the center of it and come out the other side, leaving a release bit or trigger wood on the back of the tree, an uncut section. The tree is stabilized on the back, And I can bring this bar forward, and again, using my felling sights pointed at the same object as I made with my top and bottom cut, I can ensure that the front of my hinge and the back of my hinge are going to be parallel to one another. I can bring this bar forward then and set the width of my hinge by ensuring the uncut wood on one side is the same as the uncut wood on the other side. Once my hinge is set at 10% and I have the appropriate mechanical advantage, again in a previous video, please do watch that, set, I can release the tree and allow that hinge to work as necessary to get the tree to the ground. There's a lot of other videos out there talking about not making the hinge parallel, making it triangular, and trying to offset to a lean. Some of those applications have merit, but that is advanced tree felling, and you have a lot more variables that are difficult to describe and sometimes do not control the way that you would hope. It becomes a guessing game. Certainly experience can sharpen up that guessing, but in a hinge that's parallel, there's no guessing. There's only science. And when we aim for, and we can measure this before and after the fact, and if you're new to sawing, you can actually mark the side of the tree and determine how much hinge width you want visually before you actually cut it. And I do suggest this if you are new to tree felling. So after you've made the front of your hinge by removing your face, you can make a vertical cut after measuring the distance from that face to where you want that hinge to start on the back side. And you can have a measuring device, a tape measure, or a D-tape, and you can go ahead and make a clean slit with your chainsaw vertically, and that'll tell you when to stop. You can go over and do the other side. Now this was a 12-inch diameter tree that I measured its circumference at breast height before I felled it. So it being, we wanted 80% of the face on the front of this, I got a little bit over 10 inches. So that's about 80% of what it is that I was aiming for. That's a good looking face, and you can see that my two notches met together, creating the front of this hinge at a clean apex, no more than a chain's width offset. On the back side, I was able to plunge in and draw that bar forward before anything moved or anything was released, and I was able to set the width of this. Again, I want about 10% or less, depending on species and situation, to allow these hinge fibers to move and flex as the tree comes down. When I do that, and I can double check this, if this is a 12-inch diameter tree, my desired hinge width here is about 1.2 inches. And I can just measure this. I got 1¼ inch here at the hinge. Now this hinge isn't perfectly perpendicular to the front and the back. I'm sorry, parallel to the front and the back. And that means that there's some systematic error that can be improved upon this stump. But for the most part, I have made a pretty good width hinge from one side to the other. Again, the hinge is the most important part of this cut. It is what tells the tree to stay attached to the stump during the travel motion. Once the tree's on the ground or once that face notch closes, the hinge may break, and as long as it's close to the ground, you're going to be fairly sure that the tree has achieved its destination that you had intended. Without the hinge, you have absolutely no control of the tree, and I see a lot of poor cutting done when we do stump reading, and that'll be a future video, that has no hinge control, and where the tree landed is anybody's guess. I hope it landed in the right direction. So set up and design your hinge and the plan for your hinge appropriately. Now, what happens if you are boring in or you're cutting in and you've reached a hollow? Now you know that your hinge is compromised, and that is going to potentially adjust the validity of our plan. Again, we are just in the planning process. Can I make a hinge in this tree that's going to give me the control necessary to get this tree safely to the ground? If the answer is no, based on if it's hollow or not, or if there's some other defect in the tree that's going to have to change our plan, we do not proceed, and we have to rethink before we even pick up and start the saw and do our cutting. So is the ability to set a 10% of the diameter of the hinge valid will get us into our next step, which is back cut. Stay tuned. Thanks for listening. Thank you for watching the Science of Tree Felling series. My hope is that you find these videos educational and that you learn to be a better, safer tree feller. If you know others who may benefit from this series, share the link, like the video, and subscribe to this channel. Keep watching for even more tree felling knowledge. See you next time.